Okay, it's the last week, and we'll talk a little bit more about weather, and particularly pilot weather briefing in this one. So there are lots of places to get weather information. You all probably have your own preferences. One of the things, obviously, the basis to start from pretty much on any pilot weather briefing is the current observations. What's going on now? What's happening along your route right now? What's happening upstream of your route right now? And even what's happening where you are right now. So some sources of observation, we've talked about surface observations being from ASOS and AWOS. There are other different automated observations out there as well. Uh, and these observations will typically include the temperature, the dew point, the pressure, the wind, visibility, clouds, precipitation, maybe even precipitation intensity. Uh, all that can go into your thought process as you're making a pilot weather briefing. Now you begin to add in radar. Radar provides information about where the precipitation is, how heavy it is. It gives you some information about its precipitation at different elevations. If you have access to dual pole data, which is coming, you'll have access to what type of precipitation is actually falling. You can actually see whether it's hail, whether it's snow, whether it's a mix of rain and snow, and you can actually see it by elevation. So these will be different areas, things that'll be coming in the future for you to use. And then you add in upper air soundings, you begin to get more information about pressures and how they heights and winds change with height and the amount of moisture up there, the amount of instability. There's also places where you can get atmospheric profilers, which actually give you the winds and moisture instantly at any given point. They're slowly being deployed at different spots across the country. Most of them are experimental. A lot of them were deployed from the Environmental Protection Agency. But, every once in a while you can get access to them. If you would Google them, you might actually find several sources that might be close to you. And then satellites obviously provide a lot of information about winds aloft, how at different elevations, temperatures, how they can even take atmospheric soundings, polar orbiters can do. There's a ton of information. And with GOES 16 coming along by this fall, you'll be able to get lightning data. You'll be able to get literally 1 minute observations of satellite data. The amount of data flowing from satellites out to the field, and since the Weather Service makes pretty much all data available to everyone, uh, that's all going to come out to pilots if they want to use it or not. They can actually see very high resolution surface images. They'll be able to see very high resolution infrared images, water vapor images, all kind of different possibilities with different where you can actually estimate the amount and ceilings of low clouds better. So all this will be, and even where the low clouds might be the thinnest, so you might know where fog may dissipate quicker. All this is information that's coming with GOES R, which actually GOES 16 now. There's various web pages you can go to. These are just a few. There's many, many more. Looking at the forecast process, you need to know how the forecast is going to change. Most flights in the United States are generally no more than 6 hours, so the emphasis as a meteorologist is on that first 6 hours of a flight plan. But obviously forecasts can go out to 24 hours as well. Maybe you want to know about the next day. There are all kinds of types of models out there. If you're really interested in learning about the different types, here's one web page you can go to at UCAR. If you go to the MAG, which is just a NCEP's modeling center, you can get different sectors, different weather-based models, all of this. And then you get into the ensembles, and we've talked a little bit about ensembles and the uncertainty in forecast. All forecasts are uncertain. We may put out a deterministic forecast to you and tell you it's going to rain, and we tell you that the visibility is going to be 1 mile and the ceiling is going to be 300 feet. There's a probability that there may not be a ceiling. There's a probability that that ceiling may be lower. And sometimes that probability and that information can be very useful to a pilot. And more of that kind of information is going to become available to pilots. So it's going to have to be something that they learn how to use and begin to get acquainted with and figure out how best to incorporate that into their flight planning. And finally, there's gridded aviation products that are slowly working their way out into the field. I'll take you to one in Jackson, Kentucky. There's a couple other ones around the country, and there'll be more of them coming in within the next several years, where basically you're getting an hourly ceiling and an hour visibility map, which that map is made every 2 kilometers resolution, so that if we're flying into an airport that doesn't have a TAF, maybe you can actually get a feeling for what the TAF might be like at that airport from these ceiling and visibility charts. So it's just something to look at for the future here. Finally, forecast discussions. This one's out of Charleston, West Virginia. It looks in a lot of detail about what's going to be happening and why in the forecast, particularly on aviation side. And even here, it gives you some possible alternate scenarios, the confidence they have in the forecast, and whether they have a consistent TAF or not, high probabilities, medium probabilities, and what are their concerns for that airport. So these are just some of the things that you can look at in the future. Today we'll just look at a little bit, just take on what's going on with severe weather, and let's take a look if you were flying from Oklahoma City over to Nashville today, and it's a mess. But just knowing what's happening sometimes, starting up above and working our way down. So let's take a look at upper air charts here a minute. Let's take a look at a 3-day loop of a 200 millibar chart. So what you're going to see here is the jet stream and how it's changed over those 3 days. And so we'll take a look at it here when it comes up, and it's working. There we go. Watch how it's changing. It was moving from the west to the east, and now it's beginning to buckle. See how it's changed the northwest flow there and coming down across, and so that is beginning to buckle the atmosphere, changing things from a very much east to west flow to a more north-south flow. So if you were flying out in the jet, you'd have really good eastern part of the U.S., very fast west-east flow. However, if you were in the western part of the U.S., all of a sudden their flow is coming out of the northwest, even the north almost. So you might have a different thinking about how your transportation would need to go, what route you might need to take. So let's go back to the next one, and we'll do the same thing. We'll loop at 500 millibars. Let's see what it looks like there. And you see all of a sudden this buckle coming in here. Here again, is there something that's really going down, changing the direction at 500 millibars. Good cold air advection coming into it, deepening this trough, coming into the mid part of the country. So there's going to be more and more convergence and lift in that area. Look at how the winds are shifting and coming around there. You also have something going by to the north and across Canada up here, which is going to push a cold front down through the eastern part of the United States. So let's take a look at 850 and just loop it out for 3 days. And notice lots of moisture coming across, very much of a zonal east-west flying to flow coming across the eastern United States, pushing a cold front southward, but not very fast. And this cold front's been working its way east very slowly for the last several days. However, look at all the moisture coming up out of the Gulf of Mexico now into the central part of the country. Lots of reports of flooding out there. So if you're flying out of Oklahoma City, it's going to be really tough, first off, that you can get out. But if you're going out, you've got to know that the further north you can get, the less thunderstorm activity you're going to have. But by the same token, there's lots of moisture coming up. If you got to come back south to get into it, maybe you need to even go way south down along the Gulf Coast to get away from some of the thunderstorms and along this front that's out here. So, and let's look at, with that in mind, let's look a little bit at some soundings that are out there. We've talked about soundings before. So we'll just take a look at a couple soundings right here. So let's take a look south of the front, say down around probably Shreveport area. Notice it's fairly dry in the mid-levels here. So if you're flying across, you wouldn't have to worry too much about icing or anything. But also notice a lot of southerly flow here, a lot of moisture coming in the low levels. And you notice it's very low early this morning anyways. Almost like a little bit of inversion right around 900 millibars. So as the afternoon wore on, probably the heating would come in there. You don't have a lot of clouds above that layer, so you get more heating. Your temperature may wind up over, probably into the 25, 27 degrees Celsius range. All of a sudden, you lift that air parcel up, and it stays warmer all the way up until you get way up in the upper part of the atmosphere. So you wind up with a lot of CAPE, probably have a lot of dry air in between here. So if you think about moisture coming into the drier air, you're evaporating, you're actually cooling this air down initially, even more so. So the steepness of the lapse rate is going to pick up. You don't have a real good curve as far as severe thunderstorms maybe, but you have some little bit of a curve in here, and decent winds all the way up to 40, 50 knots of wind in first 7,000 feet. So that could be something to think about on the southern side of the front. Well, let's take a look at the north side. Let's go up to Kansas City. So here comes Kansas City, hopefully. Now, let's go even north of Kansas City. What you see is you have some moisture aloft, pretty good dry layer. You're up north of the front, so you can see the cold air definitely pushed in here. Lots of clouds, above 18,000 feet, lots of mid-deck. The winds are out of the north and northeast. So you're probably going to be able to fly, in between the clouds if you were coming out at a flight level around 9, 10,000 feet. You'd be right between them. You'd have a deck below you, maybe a little bit, and even that's not too thick. Maybe even mixed out by now. So you don't have IFR conditions to deal with down at the surface. So just something to think about if you're looking at the clouds and how they move on to what you're dealing with at your forecast. So let's take one more thing here. We'll look at some mesoanalysis out there because there's so much going on. And let's take a look at these mesoanalysis, and we'll bring it in right to area where things are interesting. One thing you get with the mesoanalysis out of SPC is you get a lot of observation data. So we're going to look at the observation data. Let's take a look at some of their surface observations right now. So if you look at the surface observation, 68 versus 82. You're going to guess there's a front in here somewhere? In this area, convection is well north of that front. So there's pretty good warm air overriding. We saw that 850 moisture moving north. Well, it's overridden that warm front. Look at that, 82 down there, 81 here. There's your warm front right in this area, or even a cold front. And then back in here, low pressure forming, moving along. Out in here, you have some warm air coming up. So let's take a look at another thing of observation. Let's take a look at a visible satellite picture. Wow. You can actually see cloud streaks to the south coming up into the area. And there's your convection. And there's more clouds, probably a gravity wave moving through back in here. So if you're looking at it that way. There are lots of interesting things, lots of nasty stuff going on out there today. And finally, just looking at radar, you can see a really good, strong cluster of thunderstorms here. Some new thunderstorm activity developing over eastern part of Tennessee, western Kentucky, and down into Mississippi. So if you wanted to know what was going on right now, as far as the surface, well, one of the things as a meteorologist you look for is convergence of moisture at the surface. Where moisture is converging, it means the air's got to rise, and it means you're getting more and more moisture to work with. Well, notice where the moisture is. We were looking down southern part of Arkansas and stuff, where the flow was coming from the south, and we saw all that moisture coming up. Well, there's a good boundary right there, right along that cold front, where the moisture is converging. Even some more out here. So maybe that area might be where later on this afternoon we'll have thunderstorm development. Take a look at that. And finally, let's take a look at just knowing what's going on with how the potential cape or instability has increased. We were looking at a sounding down towards Shreveport earlier, and we didn't see a lot of things, but we said if it got some heating into it, it might get pretty unstable. Well, here's a 1500 joules of cape, which is pretty unstable, and that has now got into Shreveport, and is even more to that, higher than that somewhere to the east. So you're getting pretty unstable air down here. You've got this moisture convergence. You're probably going to get some good thunderstorms firing in a little while. So just some things to think about on the southern part of your route. Now, if you went north, not much convergence, not much in the way of instability, except maybe a loft. But so all things that make you think that maybe the northern route might be better to worry about. You can always worry about the Cape Aloft too, to see how moist it might be above you. And there is some area of moisture instability, but notice right here it kind of cuts off in southern part of Missouri. So if you went north of the convection that's going right now, you'd probably be able to stay to the north of it and maybe come into this over top of it. So let's move along to some guidance forecast. And here's your surface, and here's your front, and all that we were talking about here. Moving along, and that cold front's coming to the east as well. So say you were worried about tomorrow, and you wanted to fly out from, maybe this week from Atlanta on up to New York City. We're going to be dealing with it tomorrow, so all of a sudden now you have a front that's moved down between you and New York City. And this is at 12 o'clock, at about 7 o'clock in the morning on Saturday. And by Saturday evening, there's lots and lots of rain and all in here, a lot of IFR, and probably lower ceilings in that area. So let's take a look at model guidance with some of that and see how the models might handle some of this. Well, one of the models is the GFS. We'll take a look at it in North America. And we're just going to look at 850 millibars in surface and at precipitation. And I'm just dealing with, we'll just deal with 4 days. This is just one of many models. It shows the low coming out, slowly moving east. We saw the deepening and deepening of that trough, so it's not moving east real fast. It's really a very steep trough, but lots and lots of moisture. And notice the flow out of the northeast coming off the water into along the part of the route we're dealing with up here. And that cold front had sunk south now, and you got the more and more moisture across the southern part of Virginia and North Carolina, right on through the day. The time you're interested in flying, you're going to wind up with a lot of east wind. You really won't get any good weather until you get to New York City. And even then, you can start seeing some moisture starting to come in later in the day, tomorrow and tomorrow night, coming up off the water there. You have a big high to the north and the low to the south. So where do you get your flow? All out of the east. So let's take a look at a different model then with this in. So model back one more. So I don't want to worry about that. Let's take a look at the NAM model. Maybe we'll look at the NAM high resolution instead. We'll just go real high. We'll look at CONUS. And we want to know what's going on with looks like the radar might be doing. So let's simulate our radar. That might help us get a feel. Well, you can see one line of thunderstorms coming down across the area tonight. But look at this swirl of clouds and storms. Are really a good-looking low-pressure area. And now they've come across to the east, moving into the area on Saturday, across your whole route. Literally looking like a nice swirl pattern. Slowly, slowly working their way to the east. It's a very slow-moving system. Lots of moisture. You can actually see it coming up off the Gulf of Mexico. So just another tool you can look at with it. So now we're going to look at aviation weather, and this is out of Jackson, Kentucky. Jackson, Kentucky is one of the test sites for looking at where the tests and how how to get better hourly forecast maps. So we're going to deal with surface visibility. This just defines it. There's your 7 miles. Everybody's good through tonight. So let's move out in the future a little bit. Notice that's starting to get 6 miles coming in. There's a little bit, 5 miles more. Will it get even lower later? We only get 24 hours. Well, let's go back and take a look at ceilings. How did ceilings go with this? Look at your ceiling height, 2,500. Now you're down to the 1,500. You have some even below that, around 5, some 1,000 or less IFR conditions. And you can see, though, if you went to the northern part of Jackson, Kentucky's area, you'd be better conditions, not as low. So just some things to think about and know if, in the future you're going to be able to use these kind of products. And of course, you have all the stuff out of common aviation weather, your satellite images. One of the things I just wanted to stress too is just think about it in terms of this is not an exact forecast. Weather is not an exact science. You've been taught that. You've been shown it. So know there are possibilities, and as you begin to get more and more probabilities thrown at you, which will be happening in the next several years, understand that the weather is just that. It's a probability, your forecast. So take advantage of that and look where, if there's a real high probability that day, you can pretty much have confidence in it. If it's a low probability day, well, maybe you won't have as much confidence in it, and you might want to go with, more caution, spend more time in what you're looking at in the weather, so you can make a better forecast with it. So I hope you enjoyed the course. I really do hope you learned something. Let me know if you have any questions this week, especially with the briefing you're going to be doing and all. So good luck.